So students, yesterday we started a new chapter that is very important and interesting and a little difficult chapter, that is trigonometry. As per your order also, that is the syllabus order also, we need to start trigonometry. So month wise, in your textbook itself, in the column, the month wise topics are given. So as per that order, so we almost all completed a few chapters. Now yesterday we started trigonometry, and now I am continuing it. Now I am going to give some important formulas, and based on that we go to the exercise. Yesterday also I explained about what is angle and what are the measuring units of angle, and 0 degrees to 90 degrees we call it as acute angle, 90 degrees is right angle, more than 90 to 180 is obtuse angle, and 180 degrees is called straight angle, and more than 180 it is reflex angle, and complete 360 is complete angle. And if sum of two angles is 90 degrees, then they are complementary to each other, so they are called complementary angles. 60 and 30, 60 plus 30 is 90, so 60 and 30 are complementary angles to each other. So same way, if sum of two angles is 180 degrees, they are supplementary angles. Of course that concept we may not use in our problems. Complementary we are going to use. We have one complete exercise based on these complementary angles. So after that I gave an important relation between three sides of a right angle triangle. So in a triangle, if one angle is 90 degrees, that is called right angle triangle. So yesterday I explained about the right angle triangle. So this is a triangle. So if one angle is 90 degrees, it is called a right angle triangle. See here. Suppose if this is 90 degrees, so then this is a right angle triangle. The side opposite to 90 degrees always called hypotenuse. Hypotenuse. That already yesterday I explained. And remaining two sides, normally they called side. But with respect to the angles, we call one side as an opposite side and other side as an adjacent side. Suppose if this is the angle, suppose we are taking angle this. So this theta, this is a theta, some angle, some 30 degrees, 20 degrees, some angle, I am denoting it as theta. So then this is called opposite side. Opposite side to what? Theta. Opposite side to theta, this is called adjacent side to theta. Adjacent side, adjacent to theta, opposite to theta. Generally most of the cases we take the angle here. So then this becomes opposite side, this becomes adjacent, because it is opposite to the angle, it is opposite. This is adjacent to the angle, so this is called adjacent side. There is no confusion. The inclined side, the greatest side is always called hypotenuse, that is clear. The side opposite to our angle is called opposite side. The side adjacent to our angle is called adjacent side. So these are the names of the triangle. Suppose in some rare cases we take the angle here. So if we take the angle here, for this angle, this will be the opposite side. For this angle, this will be the opposite and this will be the adjacent. So if angle is this, opposite, adjacent, that is generally we follow. But if instead of this angle, suppose we are discussing with respect to this angle, so this will become opposite, this will become adjacent. Now, suppose we are defining, we are defining the further concepts with respect to this angle, for example. So this is theta. Now see here. See, we have the names of ratios of these two sides. So two sides. Suppose the ratio of this side to this side, there is a name of one ratio, that ratio. This side to this side, there is one name. Similarly, this side to this side, their ratio, there is one name. So ratio means we write like this or we like this. So ratio A B ratio can be written as A is to B or A by B. Similarly, this opposite side by hypotenuse. See here. Opposite side by hypotenuse. Opposite means generally we don't use opposite. We use opposite only, but correct notation is opposite to what? Opposite to this theta. So opposite side to theta by hypotenuse. So this ratio of this side to this side, that means BC by AC. BC by AC. This ratio, we have a name for that ratio. A name. So this ratio is named as sine theta. Sine theta. Actually it is SINE, but in short form we write sine theta. What is this sine? It is a name of this ratio. This side to this side, the ratio is named as sine theta. Opposite side by hypotenuse. So this ratio is named as sine theta. Similarly, this side to this side ratio, this adjacent side by hypotenuse. Adjacent means adjacent to theta. So this ratio is named as cosine theta. Cosine. That is the name of that ratio. In the short form, we write only cos theta. Cos theta definition is adjacent side by hypotenuse. It is the name of this ratio. Similarly, the name of this side to this side. So that is the ratio, the name of the ratio of this side to this side. So opposite side by adjacent side. But generally opposite to theta by adjacent to theta. So this is opposite side, this is adjacent side. This ratio can be written in the form of a fraction and there is a name for this. So the name of this ratio is tangent theta. So short form it is tan, but full form is tangent. We don't write tangent, we write only tan. Just I am giving full form also, but we write only sine, cos, tan. Next, total we have 6 ratios. 6 ratios, the names of 6 ratios. This to this, this to this and this to this. All are covered here, but same in reciprocal. Reciprocal of this. Reciprocal, that means hypotenuse side by same reciprocal, opposite. The same ratio, in reverse if you write, the name of that ratio is cosecant. In the short form, we write only cosec theta. Cosecant theta. Full form is cosecant, but short form we write cosec theta. Same way, the reciprocal of this. Reciprocal of this. What is the reciprocal of this? Hypotenuse by adjacent. Hypotenuse by adjacent is called secant theta. Secant. But in short form we write only sec. Sec theta, cosec theta. Sec theta or secant theta. Even we can pronounce it as secant, but we write only spelling like this. We don't write in full. This is, you can read it as cosecant. You can read it as cosecant, but we don't write in full. We write only short form. Next, one more reciprocal. Reciprocal of this tan. So adjacent to theta, adjacent side by opposite side. This ratio is named as cotangent. Cotangent. Cotangent is simply written as cot. So these are the 6 trigonometric ratios, and the complete trigonometric chapter based on these 6 trigonometric ratios. So we prepare so many new formulas. Exercise to exercise I will give new formulas, but all the formulas are based on these 6 definitions. These definitions only, these 6 definitions. So this is the first ratio, second, third, and fourth, fifth, sixth. So these are the 6 trigonometric ratios. Opposite by hypotenuse is sine. Adjacent by hypotenuse is cos. Opposite by adjacent is tan. Hypotenuse by opposite is cosecant. Hypotenuse by adjacent is secant. Adjacent by opposite is cot. So these are the 6 trigonometric ratios. So you have to remember this, and based on these definitions, so we move further and we go to the exercise also. Each and every exercise, again we have new formulas. For the first exercise, I think these formulas are sufficient. Yesterday I gave one Pythagoras theorem, that is very important relation between the 3 sides of a right angle triangle. And after that you have to remember these 6 ratios. So with that we can start the next exercise. So write down these definitions. So this is a name. Sine means it is the name of this ratio. Opposite side by hypotenuse. This fraction or this ratio of these 2 sides is called sine theta. So before writing this, you can write some introduction. Write down. In the adjacent right angle triangle, directly you write. No further introduction, nothing. Directly you write these 6 ratios and draw this figure. So this is the angle theta, opposite to theta, adjacent side, hypotenuse. There is no confusion in the hypotenuse. This will be always hypotenuse. But there is a little confusion in the opposite and adjacent. Suppose if I am taking this angle, this is called, because it is opposite to theta, this is called opposite, this is the adjacent. In some rare cases, we take angle here also. In that case, this will become opposite, this will become adjacent. There is a little confusion. Whenever the problem comes, I will explain. But as the standard form is like this. This is opposite, this is adjacent, this is hypotenuse. So these are the names of 6 trigonometric ratios. Sine, S-I-N-E actually, but we write only sine. This is cosine, but we call it as only cos. So this is tangent, we call it as tan. This is cosecant, we write only cosec. This is secant, but we write it as sec. This is cotangent, but we short form we call it as cot. Write down these ratios. Write neatly. Write these formulas very neatly, and because our complete chapter, this is the basic for total chapter. After writing this, students, all of you open your textbooks, 281 page number, 281 page number. So this is first exercise 11.1. our students. Now starting the problem, so be careful and listen carefully. Each and every problem listen carefully. So I will go very slow, no problem, because we are on par with the syllabus and we have completed many topics, so no hurry. And first problem in this exercise 11.1, 281 page, all of you open the textbooks and read the question. In a right angle triangle ABC, right angle triangle ABC, 8, 15, 17 are the lengths of AB. AB side is 8 centimeters. AB is 8, BC is 15, CA is 17. 17 is a big side. So you should not write 17 here or here. 17 should be always hypotenuse. Among these three sides, which is the biggest side? Hypotenuse is the biggest side. So CA, the biggest side is 17. So 8, 15, 17 are the lengths of AB, BC, CA respectively. Then find out sin A, cos A, tan A. Find out sin A, cos A, tan A. See, in triangle ABC, AB is equal to 8, BC is equal to 15, CA is equal to 17. That is given. So we are asked to find sin A, cos A, tan A. We are asked to find these three. See here, students. Just now I gave the definition of sine. What is sine definition? Sine is the ratio of opposite side to hypotenuse. So I am taking this angle. Angle A means which angle? A means where is that angle A? This is the angle A. So this is angle A. So if this is the angle, where is the hypotenuse? The side opposite to 90 degrees. It is always hypotenuse. There is no confusion. So if I am taking this as A, what is its opposite? Opposite is BC, adjacent is AB. Now, what is the sine definition? See, sine definition, just I have given the formula. See the formula. Opposite by hypotenuse. Sine definition. What is sine definition? Opposite by hypotenuse. That definition just now you have written. So for this angle, opposite is always this side only. In rare cases, suppose if we are discussing about this angle, then there is some confusion. But in most of the cases, so this angle will be taken and the side opposite to it is opposite side. So what is opposite side? Opposite is BC. Hypotenuse, no confusion in the hypotenuse. AC or CA, anyway you can call. See, we can call this side as AC or CA. Anyway you can write. No confusion. Sine definition, just now you have written opposite by hypotenuse. This is the formula for sine. Just now you have written. So opposite is what? BC. Opposite is what? BC. Hypotenuse is what? AC. BC by AC. Now see BC. What is BC? 15. BC is 15. AC or CA is 17. It is given in the problem. So this is the answer. That's all. Sine formula is opposite by hypotenuse. Just now I gave 6 formulas. So opposite is 15, hypotenuse 17, 15 by 17 over. What is cos definition? Just look at the formula. Every time look at the formula. Adjacent by hypotenuse. This is the formula for cos. What is adjacent side? This is the adjacent side, AB. Hypotenuse is AC. AB is 8, AC is 17. Write down. Always see the tan definition. All of you just look at the tan definition. Just now you have written the formula. See the tan definition. See the tan definition. Opposite. In this triangle, this is A angle. What is the opposite side? BC only. Adjacent is AB. See, be careful about the sides. What is this side? What is this side? Hypotenuse. And if you are taking this angle, so this side is called what? Opposite. This is opposite side. This is adjacent side. This is hypotenuse. Cross, inclined side is always hypotenuse. So this is opposite, this is adjacent with respect to this angle. So because A angle is taken, there is no confusion. Opposite, adjacent, hypotenuse. And we know the definition. Just now we have written. Sine definition is opposite by hypotenuse. What is opposite? 15. What is hypotenuse? 17. Where does we got these numbers? It is given in the textbook. So 15 by 17 answer. Same way cos. Adjacent by hypotenuse. 8 by 17. Tan. Opposite by adjacent. 15 by 8. Simple. Write down. Any confusion, anything followed or not, you just tell me. Followed or not? All of you, after completing this, write the second question. Second question, all of you please write down PQ is equal to 7. PR is equal to 25. PQ 7, PR 25, angle Q 90 degrees. PQ 7, PR 25, angle Q 90. Then find tan P minus tan R. Tan P minus tan R. Find tan P minus tan R. So let us draw the triangle. What is the triangle? PQR. But which angle is 90 degrees? Q is 90 degrees. So where is the 90 degrees here? This is 90, no? So let this should be Q. So keep Q here, and P and Q any order you can take. So what is the triangle? Triangle PQR. In the previous problem it was ABC triangle. So now it is PQR triangle. PQR. Now PQR. But there is a confusion. So which angle is 90 degrees? That we have to see. So which angle is 90? Q is 90 degrees. So this is 90 as per this diagram. This is 90. This is not 90. So this is the two perpendicular line means this angle will be 90 degrees. So Q is 90. So PQR is a triangle. Q is 90 degrees over. PQ is 7. What is this PQ? 7. PR is 25. PR is 25. And what is required? What is required? Tan P minus tan R. PR is, PR is 25. PR is 25, not that. PR is 25. See here. PQ is 7. PQ is 7. PR is 25. PR is 25 over. This is the problem. Now tan P minus tan R is asked. Any ratio, suppose sine is asked or cos is asked or tan, secant, cosecant, cot. If any ratio is asked among 6 ratios, so if any ratio is asked, we can find. So the thing is, we don't know this side. In the previous problem, 3 sides were given. But in this problem, only 2 sides are given. This is not given. This is not given. How to find this side? We have to find this side. Then only we can proceed further. How to find this side? How to find this side? Pythagoras theorem I explained yesterday. If any 2 sides are known, to find the third side, we have to use the Pythagoras theorem. The Pythagoras theorem is small side square plus small side square is equal to bigger side square. That is the Pythagoras theorem. Side square plus side square is equal to bigger side square. Opposite square plus adjacent square is equal to hypotenuse square. Opposite square plus adjacent square is equal to hypotenuse square. That is the Pythagoras theorem. But instead of writing opposite and adjacent hypotenuse, I will use the symbols. So PQ square plus QR square is equal to PR square. That is the Pythagoras theorem. Very simple. These two are the smaller side. This is the bigger side. This side square plus this side square is equal to bigger side square. That is called Pythagoras theorem. So write down. Given. Write down this complete problem once again. According to Pythagoras theorem. According to Pythagoras theorem. Yesterday I explained Pythagoras theorem. What is the Pythagoras theorem? This side square plus this side square is equal to bigger side square. See here. PQ square plus QR square is equal to bigger side square. PQ square plus QR square is equal to bigger side square. PQ is 7. Don't write. QR we don't know. We have to find. PR we know 25. So QR square is equal to 25 square is 625. 7 square that side 49. 7 square is 49 plus that side minus. So QR is equal to, if you remove the square, right side we will get root. 625 minus 549 is 576. Root 576, you know how to find the square root. So root 576 is 24. You know how to find the square root, you studied in the lower classes. 24 by factorizing method or by division method, you find the square root of 576, it is 24. 24 into 24 is 576. 24 into 24 is 576. So root is 24. Now we got this side. All 3 sides are known. Now no problem. You can find any trigonometric ratio. So these 2 sides only given. This is given as 7. This is given as 25. This is not given. So to find one side, if 2 sides of a right angle triangle are given, to find the another side, we have the Pythagoras theorem. This PQ square plus QR square is equal to bigger side, hypotenuse square, bigger side. In this is given 7, this is given 25, 25 square is 625, 7 square is 49, 49 that side minus 49, 625 minus 49 is 576, root 576 is 25. Now, what is required? Tan P, see the question, tan P, tan R. What is tan definition? Just see the formula. Just now. Tan definition, opposite by adjacent. Tan definition, opposite by adjacent. But which angle we are taking? P. So this angle we are taking. So for this angle, what is the opposite side? This is opposite, this is adjacent. Even we can specifically write opposite to which angle? P. Adjacent to P. Tan P means, tan definition is opposite by adjacent, but specifically with respect to this angle, opposite to P by adjacent to P. Even in when I gave the definition also, opposite to theta I wrote, but here it is not theta, it is given as P. So only P, because see the P angle. So opposite to P by adjacent to P. What is the opposite side? If you are taking this angle, this is the opposite, this is the adjacent. 24 by 7. Tan P we got. Tan R. Tan R. R is this angle. Tan R. What is the tan definition? Same tan definition is same. Opposite by adjacent. This is the tan definition. But here angle is not P. So angle is R. So opposite to R by adjacent to R. What is the tan definition? Opposite by adjacent. Opposite to R by adjacent to R. So tan definition is opposite by adjacent. I already told that when we are changing the angle, there is a little confusion. In most of the cases, we take this angle only. This is opposite, this is adjacent, this is hypotenuse. Over. But in some rare cases, sometimes as per the question, this angle we need to take. In that case, opposite and adjacent will change. If we take this angle, this is opposite because it is opposite to this. Exactly opposite, no? Opposite. But if you are taking this angle, this will become opposite. So this will become adjacent. So opposite to R. What is opposite to R? 7. By adjacent. Adjacent is how much? 20. Tan is equal to opposite by adjacent. 7 by 24. But if you are taking this angle, opposite by adjacent, 24 by 7. So now we got both the values. What is the required question? Find tan P minus tan R. Tan P is 24 by 7. Tan R is 7 by 24. Do it. Take LCM and do it. Right now. Seven into 24 is 7 fours are 28, 2, 7 to the 168, 7 576 minus 49. See that simplification, you know how to simplify. Take LCM. 7 into 24 is 168. 7 24 times 24 into 24 576. 7 into 7 49. 576 minus 49 you do and check the answer. Students, just tell me followed or not, understood or not, understood or not. Understood or not? Is it visible or should I write again?